Looks like the Fender tank is a good fit for the Kalamazoo. Nice smooth reverb action. While we're at it, why don't we check out that tremolo circuit. Hey everybody, welcome to D-Lab. This weekend in Arctic, Michigan, I get to work on a beautiful Kalamazoo Model 12 reverb amplifier. A friend of mine bought it on reverb.com, I think, and he received it, and unfortunately it was not as expected. The output is very low. Reverb and tremolo are in-op. He sent me some pictures. This amp has been recapped, but some things are obviously overlooked. So let's fire it up, see what it's doing, and then we'll pull the chassis and see if I can spot something. Let's go. So just for reference, I have a guitar here. Plug it in. You can hear that tube. Okay, I'm going to bring the volume all the way up. That's it. That's all you get out of her. You can hear the ringing of that microphonic tube. So that's about all I need to hear. Let's get the chassis pulled, give it an inspection, see if I can spot something. I'm sure we're going to find some out of tolerance resistors, maybe some grounding issues causing that background hum. I got the back panel pulled and the screws that hold the chassis are out. So I'm able to slide her out here. Get that pedal cable off. You can see some of the caps have been replaced. These are just the power supply filter caps. It still has some of those little brown milk duds in there for the coupling caps. But at this point I'm really not concerned about that. But I want to get this out so I can give her a good inspection. I already see one thing that looks kind of alarming. It's on those input jacks. Let me show you. Alright, here's the chassis. She looks pretty good. You can see the new filter caps installed. All the resistors pretty much look stock except for the input jacks. Take a look up there. Somebody's been in here. You can see that this resistor has been changed. There's another lead hanging out behind it. These are 8.2K resistors. I believe those are supposed to be 68K resistors. The 1 meg guy's there, and this 2.2K has also been replaced. Let's take a look at the schematic and find out what those input resistors should be. Alright, I've got this nice schematic pulled up on my computer out here in the shop. Here's our instruments input, the 1 meg, and yep, 68K resistors, just like Fender did. So for the fun of it, let's measure pin 2 to ground and see what the resistance is at this point. I betcha it's pretty low and it's just swamping that input. I have a 1/4 inch input plug installed just to open the shorting contact on input 1. So grab our meter and let's check input 1 to ground. See what we got. If I can keep my meter on there. 17.8K. Okay, that's pretty darn low. Let's go right to the input of the 12AX7, and this is normally supposed to be about a meg to ground. Look at there. I got 8.7K. Alright, and that's probably due to these very low value resistors that have been installed on the input jacks. Alright, there's one other thing I have to show you. So not only do you have the resistance of these resistors affecting the gain, so the input jack is coming in here, but then it's looping back through this resistor, and this jack is tied to ground. Okay, so that will also affect your gain. Then on this amp, I'm going to have to get a different camera angle and show you guys something else really cool. And what's that cool thing? Well, they had a tape phono input also on this amp, and look, you see there? They're shorting contacts, so when you're not using that, it also pulls this 68K resistor to ground, further loading pin 2 of the 12AX7. Let's take a look at that input jack. Alright, there it is. And he is over here, and there is the 68K resistor that's going to the 12AX7. So if I take my meter and go right there, you can see we're shorted to ground. All right. So to get more gain out of this amp, obviously we want to eliminate this connection since you'll never use it. We need to put in the proper 68K resistors up front, but even better, we're going to wire these input jacks like Fender did so that the loading of channel 2 does not affect channel 1 when you're not using it. Well, there they are, 8.2K resistors. We're just going to carve those guys out of there. Okay. I'll clean things up as we go. I don't know why somebody would have elected to put in 8.2K resistors. You can see they just tack soldered them on there. Lovely. And it looks like there's remnants, maybe, of the old resistors that were there originally. So we're done in a hurry. I need to get in here and make it look nice and pretty. And then we're going to swing the jacks around and wire them up like Fender did. Okay, so Fender has the input that goes direct. Its switched output enables this jack when you use it. But when you're not, it won't affect it. I think it's a great system. Easy update and very reversible. Alright, there's our new input jack wiring with 68K resistors, and the jacks are configured per a Fender Princeton layout diagram. That rear jack that had the 68K resistor that was also going to the 12AX7, I simply cut a little coaxial cable. So that will have no effect now on the sound. So let's grab a meter, measure the input jacks, and see what the new input resistance is. Alright, same deal. I just plugged in a 1/4 inch jack to open the shorting contact on the input. Let's take a look on the meter now and see what we got. Look at there. Almost 1.2 meg. Remember what we had before? I bet you we have a lot more gain. Let me get this thing hooked up. We'll do the same test with that guitar. Okay, same test. Got the guitar hooked to input 1. Loudness control, let's take it up to about 3/4, see what we get. Now the speaker's facing the other way. I don't know if that's really going to affect anything. There's full volume. So you can see she's a little more lively since the 12AX7 is getting a good input signal now. Alright, next, let's see if we can get rid of this background hum and then fix the tremolo. And then we'll go to the reverb. Alright, so I made a little discovery on the tremolo circuit. If I take and ground the input directly, you can hear it's working. So tremolo is okay. It's probably just the foot pedal switch that's causing that issue, and that may also be causing the issue with the reverb. Wouldn't that be cool? So at this point, I'm not going to worry about tremolo, but I would like to address this background noise. That is really excessive. We should not have that going on. So that's the next thing we're going to do. Moving right along on the Kalamazoo amp, I'm going to start checking into this reverb issue now. So obviously the first thing to do is check the tank. That's the most common failure. So I got my meter set up here on K ohms. Let's see if the coils are there. Yep, there's that one. That's a good sign. This one here plugs into the transformer above with these spade terminals. Yep, nobody's home on that side of the reverb. So next step, let's pull the tank and inspect it. I do not believe that the reverb tank is the original one that came with this amp. Look at there, schematic. Nice and handy. Alright, so I get all this stuff out of my way. Pop the screws and we'll flip this thing over. So the coil is pretty loose, but it's probably normal. So it looks like we got an open coil. That's a bummer. Go ahead and check the other one. We already saw that measure good though, but just to show you that my meter actually works, here's the other coil. Yep. Okay, we're going to sub in a reverb unit and see if that solves the problem. So to check the reverb, I substituted in a Fender type. This is the 4A B3 C1B reverb. Connectors go right on it. Let's see what happens. I got it fired up using my leader audio generator as an input. Reverb's all the way down. Let's crank it up here. Let's see what happens. Yep. So it looks like the Fender tank is a good fit for the Kalamazoo. Nice smooth reverb action. While we're at it, why don't we check out that tremolo circuit. So the reverb's nice and quiet, that's a good sign. Obviously the Fender tank is a good matchup for it. So let's play real quick with the tremolo. I'll jump that on. Yeah, you can hear it. Alright. So we've got the reverb working, tremolo is working. The only thing I need to address now is this low level hum. Because even without a signal applied, get this tremolo off here, there's a bit of a background hum that I'm not very happy with, and it's also still microphonic. I believe that is those output tubes. We'll just keep eliminating the problems, but man, she's getting close. So I'm in here looking for that source of noise in the Kalamazoo, and I did notice this. Here's our filament lines. On the schematic it shows one filament line to ground. Well, somebody raised these above ground with 100 ohm balancing resistors, just like Fender did. And that's cool, I've done this many times. So you can see the filament lines taken off with the twisted pairs and they wrap around here. But then I started looking at tube V1, which is our input tube, and if you look right down there, you'll see pins 9 and 8. They're both connected to the filament line. The black line used to be ground, it's not anymore, so now you got 6 volt AC sitting on 9 where it should be, but it's also on pin 8, which is one of the cathodes of the preamp tube. So let me reverse that. I bet you it'll make a world of difference. So I got V1 wired correctly now. Looking over this amp, I see something that I really don't like, and it's going to be very difficult for me to correct. There are so many ground points in this amp. You know, rule of thumb guys, it should all try to terminate to one central ground point. I mean, look, we got our power coming in here to a pop riveted ground connection all by itself. These filter caps wrap over here to this terminal. It's kind of globbed over to that terminal. They have another ground coming off the center tap here for the filaments. I mean, it's like grounds every which way, but none of them totally bonded properly to the chassis. So what I'm going to do is I'm going to land another terminal strip here, and I'm going to bring all these grounds to that strip, and it will be soldered direct to the chassis. And let's see if that makes a difference on this background hum that I have with the Kalamazoo amp. Well, here's the deal. I've cleared an area for another terminal strip. I ground the metal a little bit to get a good bite. This guy is going to go in there. We're going to pop rivet it in place. And then I'll solder it, okay? Kind of hard to do all this, not block the camera, sorry. Do my best. Alright. So in case you're wondering, these are metal pop rivets, okay? So they'll solder really well. I do not use aluminum pop rivets because they have a tendency to loosen up. But of course, after we solder this, it's going to be permanent. Alright, pop rivets in place. Of course, to get that proper bond, we need a pretty powerful soldering iron. And what would that be? That's right. Snowzoramus on the job.
Sit back, relax, light up an old groove. lot of people wonder where ghouls come from. Well, they come from all over. They have a lot of ghouls come from Portugal.
Well, now we have a secure chassis bonded type ground, and I'm going to swing the power cable. We're going to remove these two balancing resistors, put those over here, swing as many grounds as I can to this point, and I'm going to run a strap from here to this other crappy pop riveted ground. Let's see what that does. Alright, got the new grounding installed. Didn't seem to make a whole lot of difference in that background noise. It's kind of a bummer. I did find that if I take my hand and grab the reverb tube, watch. Hear that? So it appears to be coming in through the reverb tube. I'm going to see if installing a shield might cut down on some of that noise. The other thing we still got going in this output tube, she's very sensitive, okay? So I need to get a new set of EL84s installed and see if that also helps to reduce some of that noise. I've received some new EL84s for the Kalamazoo amp, but I'm still trying to resolve this noise floor issue. I talked to the owner and we both agree that the current power on switching, which is on the treble control, should be relocated to a front panel toggle switch like this beautiful Carling. Okay, so what the plan is we're going to relocate the fuse holder to the rear of the chassis where the AC power comes in, and that will eliminate the AC that comes across through the preamp section to the back of the treble pot. Let's see if removing that and rerouting the AC calms down some of that noise. So the beauty behind reversing the power switch and the fuse holder is they both utilize a 1/2 inch hole, so this is 100% reversible. I'm getting ready to put in the new EL84s, but first I want to check the high voltage and the bias through the current EL84s because they're running hotter than a firecracker, guys, so I'm kind of concerned about it. So let me get my meter here where you might be able to see it. Got to do a bit of a balancing act. Hold on. Alright, my meter's balancing up there. Let's see what the high voltage is on the tubes. We're at about 312 volts. Okay. And here is the 100 ohm bias resistor. You hear everything I touch? Ping, ping, ping. Yeah. What we got here? Oh, come on, meter. Oh, there it is. 9.5 volts across 100 ohms. Let's see what we get. That equals 95 milliamps, so if you divide that by 2, it's about 47 milliamps per tube. I checked on the Weber bias calculator. At that high voltage applied, it should be no more than 30 milliamps. So before I put in the new tubes, I'm going to change that 100 ohm resistor to something higher and bring that current down so we don't just destroy our new EL84s. I got the new EL84s installed. I'm monitoring the voltage across the cathodes right now, the new resistor value, which turned out to be 200 ohms. So now we've got 12 volts across 200 ohms. And if you divide that by 2, it's 30 milliamps per tube. Pretty much exactly where I'd like it to be. So now they're not running too hard and the noise level actually went down, and of course the microphonics are gone. So we're making some progress. Alright, here's where we're at on the Kalamazoo amp. It is operating. The reverb does work. But I still have this background noise, which I've been trying to eliminate, and that's been very difficult. But the other problem is the tone circuits in this Reverb 12 suck. Okay, they're not really tone circuits. They're more of like frequency cut controls, like the high frequency cut, and the bass is actually kind of a frequency cut. So watch the bass response here. Let me go down to frequency and watch my bass control. Swoop, swoop, and then it just gets nasty loud. This is the stock configuration. So I talked to the owner, and he said, you know, that amp is pretty much a total loss at this point. It's not even usable. So we discussed this and decided that we're going to change the tone controls to like your Fender Princeton style, okay? Because we know those controls work well. The only issue is these two pots are, I believe, 2 meg a piece. Let me check, do a little schematic here. Yeah, these are 2 meg pots. So we need to step those down to 500K pots. Then the volume control right now is a 500K. I'll probably just leave that alone. But we're going to convert the tone stack to Fender and see if the tone actually works. And maybe that will also give more response to the reverb, because the reverb is actually tied into these janky tone controls. Okay? So that's what we're going to do. And yep, it's going to change the originality of the amp, but it's going to make it usable. So here we go. Alright, so you can take a look. Right here is their crazy tone system. You can see that the treble is definitely just a high cut, but the bass, to tell you the truth, I have no idea what the heck they're doing. We're swooping back and forth with a 2 meg control. There's a 500 puff strapped across it. It's just insanity. I don't know what they were thinking, but that's got to go. So we'll put in a documented Fender circuit. Alright, so the changeover, the tone control shouldn't be bad at all. There's the treble, there's the bass pot, and we're going to come off with this 12AX7, and there are some unused terminals here on the board. So it shouldn't be too bad at all. Let's get going. Now here's what I ended up doing. I put a 1 meg pot in the place of the original volume control. These are both 250K pots, just like they show on the Fender schematics. So we're ready to wire her up. Alright, the new tone circuit is installed. I just took the Fender basic tone circuit like you'd see in a Princeton. So we have a pair of 250K pots for bass, treble. Volume pot is 1 meg. You got your typical 100K resistor that feeds the 0.1 and the 0.047 cap, and of course your treble cap is going up direct to the treble pot. So it's a pretty easy install, and it really did help the tone on the Kalamazoo. Let me show you. Now here we go. I'm going to demonstrate these tone circuits real quick. Just use a guitar. You guys can hear the new response of the bass and treble controls. Now remember, we had a lot of background noise and the volume was low. Now listen to the background noise. It's like half of what it was. Okay, there's full volume. Okay, before there was so much noise that you wouldn't even hear a volume increase until you're about halfway. But look, you can hear her. She's trying to amplify. Alright, so if you take your guitar, bring her up. Lots more volume. And listen to the bass and treble response. Here's her bass. These are working just like they do in a Fender amp. It was a great improvement to the Kalamazoo. The only problem I still have is the reverb level is still low. It's there, it's working, but it's weak. I need to discuss this with the owner. Here's where we're at on the Kalamazoo 12 repair. Tone circuits are straightened out and working perfectly by using the Fender design. What they had going on in here, I can't tell you how it ever worked. It was terrible, and it caused a lot of background noise that was greatly reduced with the new tone circuits. Tremolo is working fine. The problem was the switch in the foot pedal. So that guy's working as it should. Reverb is still light. I can hear it on my audio generator, but when you hook up the guitar, it's kind of just barely there. So I'm not real happy with the reverb, and I talked to the owner. I gave him some options, but unfortunately it's an expensive option. It has a Fender reverb tank in it currently, and to get it to work right, we'd also have to put in the Fender circuitry, which would be quite a job. So he is elected at this point to stop the repairs. He'll play it the way it is, probably use a reverb pedal, and maybe in the future we'll get back together and put in that Fender spring reverb circuit. But at least the tank's in there and some of the supporting electronics is waiting. So until that point, D-Lab's taking a mission complete on the Kalamazoo 12.